Good afternoon, everyone. Can you hear me?
Yes, ma'am.
Okay, thank you. I think my computer has some stuck, so that's why I got a little bit late. Okay, anyhow, let's start our course. Okay, so is that everyone here? 90 only. Okay, and hopefully this is our final lecture. Okay, we are in the chapter number 4. We have seen numerical methods solving differential equations. Under that, we have seen Euler methods, Taylor series method, as well as Runge-Kutta method under the single step method. Also, we have another multi-step method only remaining, so we can finish up today. So these are the last lectures one about the single step method. So first one we have seen Taylor series method as well as Euler's method and also the Runge-Kutta method. Hope you have gone through again. Runge-Kutta method also we have seen 2 orders, second order as well as fourth order. So there's nothing, just to memorize the things, as like if you get the idea, it will be very easy for you to memorize. Okay, hope you have done the homework quizzes as well as, okay, and the exercises, you have finished exercises as well. And like what as I said you in the single step method, okay, single step method, it is required only one step away, isn't it? From y naught to, if you want y1, you can use the y naught values which has been from the initial value, you can jump up to the second value. So if you wanted to go y2, you can use the y1 value. Okay, so from y naught you can find the y1, from that y2. Okay, now let's see the multi-step method. Okay, I have sent you these notes. So I don't want you to write anything, but we can do some exercise as well. So I'll use these notes just to explain you. Okay. So you can see, get the notes from, I have sent you the module, so you can write down those things. Okay. Now the multi-step method says to compute the value. So to compute the value of y at xn plus 1. Let's say you have to find the value of xn plus 1. For example, what is y of 4? Like that. Okay. So, and if the value of y are at more than one preceding tabular points. Some of you has not off the, mic. Can you off your mic, please? Right. So to compute the value of y at xn plus 1, if the value of y at more than one preceding tabular points are used. So they have given, let's say, for example, if you wanted to find y of 4, let's say they have given you y of naught is what, y of 1 is what, y of 2 is what. Okay. So they have give up to, let's say 0 to 3, they have to give you the tabular values of these values. So multi-step, they have to give you. Then from these values, you can find the whatever the R's values. Okay, so that's what it calls as a multi-step method. Okay, then the method is known as a multi-step method. Sometimes there may be a question like define multi-step method or define single step method. Okay, so go through these things also. Okay, okay, so that's just a introduction on these. Okay, on this multi-step method, we are, okay, let's go for another heading, which called as a predictor corrector or prediction correction. Okay, so we can also say prediction. So what do you mean by prediction? Prediction means, so we are approximately thinking, okay, this one will be. Then using the prediction, we are correcting our thing, okay, modifying. So this is kind of a method which involves the multi-step method, okay. Let's see what it is. In practical, the multi-step methods are not used to solve the problem. Rather, okay, so they usually there is nothing like that, okay, multi-step method, which can be solved problem. But if they are used to improve the approximation obtained by explicit method. Okay. So do you remember what I also explained you what you mean by explicit method? Explicit method, as well as what is the opposite of this one? Another form? Anyone remember? Can you chat with me also? What is the other form of explicit? Okay, I got one answer. At least today is our last lecture. No? Please, everyone, please, can you communicate with me? And yes, good. Okay. Okay, one more person. Explicit. Another one. Yes, others. Okay, good. So explicit, implicit. Okay. Explicit and implicit method. So explicit in the sense, okay, we are using our past data to find our new value. Okay, one more step. We are using our past values. So implicit in the sense, we are using the whatever the value you are finding, that is also involving in our equation, which called as a implicit method. Okay, so you can see it says in practical multi-step methods, methods are not used to solve problem. Rather, they are used to improve the approximation obtained by explicit method. So you will get something, okay, from the explicit method. So that approximation can be a little bit improved by this method. Okay. Also, the combination of the explicit method to predict and implicit method to improve the prediction is called the predictor corrector method. Okay, so you can say in this multi-step method, okay, we're gonna have the two steps, which is one is a prediction, another one is correction. Okay, so prediction in the sense it is involving the explicit way. Okay, explicit method. Correction, it has the uh, implicit equation. Okay, so the combination of both are involving which we called as a multi-step method. Okay, also called as a prediction correction or predictor corrector method. Okay, the combination of the explicit method to predict and implicit method to improve the prediction. Okay, so improving the explicit method is which called as a implicit method. Okay, so that is involving in the correct way. Okay, so both altogether we called as a predictor corrector method. So this is also one of the definition. So please understand it. Okay. Okay. So let's go further. Okay, there are two main methods it's involves in this coursework. Okay, so for the multi-step method, we can see there are two methods which known as the one we call Milne's method. Okay, so that is if you know this one is little bit tricky one. If you know this one, that one is very easy. Okay, so Adams Moulton. So Adam is one of the person, Moulton is another person. Okay, that's why their both name has been included in their method. Okay, so you have to use a capital A and M for because people's name. Okay, Adams Moulton, fourth order prediction correction method. Okay, so we are going to find for the fourth order. Since it is a multi-step method, we can find for the fourth order. Okay. So the Milne's method, I'm not gonna because of the time duration of our course, I'm gonna make you to the reference. Okay, but it is for your knowledge. Okay, if you have time, you have to please refer it, okay? Because it may come for you in the later part of your these courses, okay? So it's better you to just go through any books or anything or to find out what is Milne's method. If you know the Adams-Moulton method, Milne's is nothing, okay? It's a simple one, okay? So that's why I have taken the harder one to explain. Then the simpler one you can refer yourself, okay? And also you can see Milne's method, it has depend on Newton's, you can check that equation has involving Newton's forward interpolation things, okay? Interpolation. Similarly, the Adams-Moulton has Newton backward interpolations. So I'm not gonna spend time on this, okay? Because we already studied this one very well, okay? So only thing you have to know, Adams-Moulton has the idea of Newton backward interpolation. Milne's method has a form of Newton forward method. So you know earlier also when we are doing the forward is easier than the backward, no? So I hope the Milne's is very easy for you, okay? Only thing is you have to find what is the equation of that, okay? All right. So let's begin the method what we are going to study, okay? So anyway, you don't need to worry about the examination purpose, okay? Examination, whatever I have explained, I will take it, okay? Other references will be, maybe sometime I may take, or otherwise it is for your knowledge. But it's better you to, on that time itself, today or tomorrow, you just go through the Milne's method is what? That's all. That's enough, okay? You just write down the whatever the notes you are getting in your notes. That's enough, okay? But it is very important for your further studies. Okay, now give me a second. Okay, let's study about the Adams-Moulton fourth order prediction corrector method. Okay. Now, the thing is like what our methods, okay? This one has four steps, okay? These are the 4 steps you have to consider to solve the Adams-Moulton method, okay? So the derivation and things are not in your course, but if you are interested, you can go through some books and all, how they have, got this one, okay? So what the multi-step says, okay? Let's say they have given what is yn? What is yn minus 1? What is yn minus 2? What is yn minus 3? Okay? Let's say they have given you what is x starting point. X naught is what? Okay? Also h. H is what? Usually our h is what? It's a, can you answer me? What we called as a h? Okay. Yes. Good. It's a difference between the other point, isn't it? Or otherwise we can say steps, other step, okay, other distance, okay, other difference. All are correct, okay. X naught to x1, how many? The space value, isn't it? What is the interval value between these 2 points? Okay, good. So likewise, so we know h. Let's say they have given you x naught and h. So from that you know, no. So since I told you this is Newton backward and forward involving, you know, x1 will be actually x0 plus h, isn't it? And x2 will be x1 plus h. So equal length has been increased. Okay. So let's say they in the multi-step method in the definition as it is, it's saying what? So if you wanted to find, let's say I need to find y3. Okay. So how many point I need to get from the tabular value? how many points they have to give you. So they have to give you y0, y1, y2, isn't it? Then only we can find the y3, okay, from the using this multi-step method. So see here, let's say I need n plus 1th value of 0. Okay, so y0 x plus 1, which is equal to, so this is somehow you have to memorize. Okay, there's no way. But if you're interested, you can go through how they have derived this equation and all. Okay, but actually it's a big, maybe the big process. Okay, so they may use the Newton's backward forward, I mean interpolation formula, and get this value should be, you have to know. Okay, so it's actually, if you wanted to have the y0, this is step 1 is you have to find the yn plus 1's node value, which is equal to yn plus h by 24. 55, the value of this, okay, function value of this one. I will tell you how to do that in examples, okay, but let's understand the algorithm first, okay, what is the, equation. So next is, this is 55% of the function of yn xn, okay, then minus 59, okay, I will take off this one. See here, minus 59 times the next term of this one. So we know y0. So sorry, for example, let's say I need to find y of 4. Okay, so here this one is my y0. Okay, this one is my y1. This one is my y2. This one will be my y3. Okay, so this one is just a yn, but this one is what? Function of whatever the function they have given. Actually, what is our function? We are now in the chapter 4, we are solving the differential equations, isn't it? First order differential equation. So it is like whatever the f of x, y, let's say they have given some example, equation. Okay, you have to substitute that value. Okay, so we can do the example and you can understand. So 55 f of this one minus, this is somehow you have to memorize. Okay, so minus 59, 37 and minus 9. Okay, and then step 2, this is actually the prediction equation. Okay, prediction 1. Okay, this is our corrector. Okay, from this, the next value of this one, yn plus 1 of 1, which equal to yn plus h by 24, 9 times, see here. So I said you the predictor value is for explicit, no? In the explicit, in the sense, it won't come the earlier past value only involved. See here. So since they have given y0, y1, y2, y3, you can substitute and find the value. That's all. Okay. So first of all, you have to find the 0th of yn plus 1. Okay. Then first of this one, the corrector one, it says yn same h over 24, 9 times, see here, x of n plus 1. See, we already n plus 1 only, but n plus 1 also inside the equation. So that's what we called as a implicit, no? Implicit case. Okay. So that's what it's happening. They are modifying from prediction to corrector. Okay. So whatever the value you are putting here, you have to put. Okay, yn plus 1 not. Okay, next one, 19 of this one, x and yn, minus 5 times of xn minus 1, yn minus 1, plus 1 time fx minus 2, yn minus 2. Okay, so these two are anyhow. Okay, all these steps you have to memorize. Okay, if you do, I have allocate you 2 or 3 questions. If you do that again, it will be automatically memorized. Okay, you don't need to worry. Okay, that's why I have limited my course until only for the Adams. For the Milnes, I didn't go. Okay, so Milnes, I hope this is easy than this, so it is okay. Okay, so step number 3. So after you are finding the predictor and corrector, you have to find some so which called as a difference, like dn plus 1. Okay, and at the point of n plus 1, what is the differences, which can be given as like this. 19 divided by 720 minus 19 divided by 720. So whatever the value you find here minus this value. Okay, this value minus this value. See here, yn plus 1, 1 minus yn plus 1, 0. Got it? Okay, now one more. Last position there. Okay, I'll erase this one. Last point is nothing. So what this is our approximational value, okay, which known as this value, okay, yx x plus 1. For example, y of 4 is what? Okay, y of, 0.4. So if you know 0, 0.1, 0.2 value, 0.3 value, how to find the 0.4 value? Okay, that's what we are doing. So these value, x value, we know. Using the y value, function of dy over dx, we can find the y value, okay, or otherwise they may give you the y value, so no problem. Okay, so using that you have to find this one, okay, character value plus the difference we called as a finalized answer. Okay, so this is actually the Adams Moulton method. Okay, there's nothing, only the equations. Okay, if you get the equation correctly, that's all. There's nothing, just to substitute the things. Okay, let me do the exercise so it may give you some extra ideas. Okay. So I didn't put the homework quiz for this one. I have put the questions as it is in the, okay, give me a second. Okay, let's do our first questions. Can you write down the questions so we can start up? So the question will come in this way, okay? Using the Adams-Moulton fourth order prediction corrector, or it also known as a pair of modifiers, okay? These are this is modifying this one like that, okay? Pair of modifiers method computes the value of y at x equal to 1.4. So what they're asking for, what is y of 1.4, okay? They have given the fx comma y. So we know dy over dx, no fxy. So this we called as our differential equation fx comma y. So which is given as this way, xy plus y x squared minus 1. Okay. So whereas spacing also they have given 0.1. Okay. So from this we're going to find out what is y of 1.4 using the Adams-Moulton method. So they may give you this method, only you have to use. So this question you can't go for other methods. So if they ask you the particular method, you have to use same like a single method also. If they ask you to do the question using the Taylor series method, you can't. If you only studied Euler method, you can't use it. Okay, you can get the answer correct, but that's not a question, no. So you may get some 0 marks. So you have to know all the method. So whatever the method they are asking in the question, you have to answer according to that method. Okay, so shall we start this question? Okay, let's begin. So they ask you to find y of y at the 1.4 value is what? Okay, for the dy over dx, they have given xy plus x squared minus 1. H is 0.1. Okay. Since in the Adams Adam-Moulton fourth order, okay, actually you have to start from y0, y1, y2, y3. Then only you can substitute, no? So according to that, you have to know x0, x1, x2, x3. I think I didn't give you the x0 values. Okay, anyway. So let's say x0 is equal to 1. Okay. Please write down this one under that question, okay? I think it should given. y naught is equal to 0.649. I thought I have, okay. X1 is equal to 1.1. Y1 is equal to 0.731. So this is the tabulated value. Okay. So they will give you in the question. Don't worry. Okay. Sorry. So these are the tabulated value. Okay. Data values. So X2 like that. So what will be the X2? You know the H, no? So you know 1.2, isn't it? So Y2 will be 0. Let's say 854. Okay. X3 will be 1.3. Y3 is equal to 1.028. So from this, they are asking you to find the Y4. Okay. Yn plus 1, no? Yn plus 1. So it should be Y4. Okay. So this is the question. So see here, to get the Y4, since it is a fourth order, you need Y0, Y1, Y2, Y3 values as a multi-steps. Okay. Okay. Shall we begin now? So from this, okay, x0, y0, x1, y1, x2, y2, x3, y3. First of all, you find this is equal to fx comma y, no? X comma y, maybe xi, yi, okay? So you have to find this one. Then only you can substitute, no? So using these values only, we can find that one. Okay, let me begin. So first of all, let's begin. Consider f of x comma y, which is equal to dy over dx, fx comma y, which has been given as xy plus x squared minus 1. Okay. So let's first of all, let's find out what is, let's name this one as f naught. Okay. F naught as f of x naught, y naught. Okay. So I have given, no, what is x naught? It should be 0. What is y naught? 0.649, isn't it? So can you substitute these values in this and find this one? What is actually this one, f naught? Can you answer me quick? Using the calculator, you can answer. So only thing is 0 times 0. So this will be 0 plus 0 minus 1. Very easy, no? Sorry. X naught is, did I give you 0? Okay, give me a second. Okay, 1, no? Sorry, yeah. So this is 1 time. Mm. Okay, sorry. Okay, now find it. 1 times 0.69 plus 1 squared minus 1. So 1 and 1 cancel out. 1 times, very easy, no? You can do without calculator also. So correct? How come minus 1? Sorry, you have taken 0, no? Now can you find it? See here, 1 time, yes. This will be 1, 1 minus 1 will be 0, no? Okay, good. Okay, similarly, can you find f1? So there you have to use x1 comma y1 the same way. Okay, you substitute and find the answer. Similarly, you have to go up to f3 because we need to find the f4. That is the actually the thing. Okay, so can you go for this one? F of x2 y2. So using the data values has given, you can find this one. Okay. Okay, can you answer me quickly? Okay, give me a second. Okay, so is this 1.0141? Okay. Okay, let's keep as it is 3 decimal places. Okay, 1 can be. Okay, you can, no problem. You can put 1. Okay, what about F2? So you have to substitute F of this one will be 1.1, no? 1.1, comma 0.731. This will be 1.2, comma 0.854. Sorry. So this will be F of 1.3, comma 1.028. Okay. So using this one, simply we can find. Okay, good. 1.4648. Okay. What about this one? Okay, good. 2.0264. Correct. Okay, if we find this one, that's all. We have to go for our steps. Okay. Okay, please, others also do you think so correct or not? Yes. Let's begin our step 1. Okay. What is actually step 1? You have to find the predictions. Okay, here yn plus 1 of node. You write the equation again. Okay, yn plus h by 24. Write again. So then it will be memorized. Okay. So 55 f of xn comma yn. See, this is going backward now. That's what the Newton's backward. Okay. Yn minus 1 and yeah. Then plus 37 f of xn minus 2 yn minus 2. 9 times f of xn minus 2 yn minus 2. Okay. So just substitute. So if you wanted to find y4 of 0, we have y3 plus 0.1 divided by 2. Okay, first of all, let's put. Okay. So 55 times. So what is this one we got? This is like F3, no? F3. Okay. Minus 59 F2. Okay. 37 F1 minus 9 F0. Okay. So we have named this for the easiness. We have named this. Now you can memorize easily. 55, 59, 37, 9. Plus minus, plus minus. Okay. So Y3 actually, what is that? 1.028. Isn't it? So H will be 0.1 divided by 24. Times. So 55 times. So what is our F3? Last point here. This one. 2.2. Okay. 2.0264. Okay, can you substitute and find the final answer? 4648 and 37 times 1.014. You can put 1 and minus 9 times 0.649. Okay. So just substitute this in the calculator and find the final answer. See whether you get this answer. 1.264274. Maybe it will be wrong. Please check yourself. One 1.264274. 4289583. Okay, no problem. Anyway, something 3 digits, 4 digits are coming. Okay, no? Yeah. So someone has answered me. How come 1.878? Can you check your answer? One has answer 1.264274. to 89583. Okay, maybe that's correct too. Okay, because we also have used some extra term also, no? Okay, maybe correct. Okay, since check whether you are okay. So don't worry about my answer. Just take your answer. Okay. So okay. Shall we continue? Others? What about the others? Everyone getting? So now itself don't, approximate it. Just keep it as it is for some time. Okay. 2, 4, 6, yeah, something. Okay. Let me go for the second step. Step number 2, which is for the correction. Okay. Before that, okay, before the step 2, since step 2, we have some this value also involving, no? So what is actually our corrector value? I mean, step 2, we have yn plus 1 of 1, which is equal to yn plus h by 24 times 9 of f of xn plus 1. Again, it's a yn plus 1 of 0. Okay. So, which is kind of, I can say, y4. There are some more as well. You can write that. Okay, h by 24. This I can, abbreviate it as f40. No, sorry. How I supposed to write? Sorry. Yeah. f40. Okay, so this is, so if it is, let's say, y of xn plus 1, yn, sorry, f of xn plus 1, yn plus 1, I can write as a y4. Sorry, f of 4. Because, sorry about that. See here, in this, I have abbreviated x naught, y naught, I have put f naught. x1, y1, I put f1. x2, y2, f2. x3, y3, y3. Sorry, f3. Likewise, okay. So how I supposed to, abbreviate this one with respect to xn plus 1. Okay. So since that is a function of xn plus 1 times yn plus 1 of 0. Okay. So how I can abbreviate this entire one f of xn plus 1 yn plus 1 as f of 4. Okay. So if the 0 involves, I can write this one 0. Okay. So because I don't want to find here, so I'm going to separately, first of all, I'm going to find it. So I can put here directly, no? Okay. So in that sense, okay, f naught 0, which is equal to f of x4 comma y4 of 0. Okay. Did you get that? So f40 means f of x4, that this one, no? Because we are dealing with n is equal to 3. Okay, I'm sorry, I didn't put that there. So from before this step 1, you have to know we are going to find the n is equal to 1. N is equal to 3, sorry. Then only y of 4, no? Because already 3 values are there. So if you wanted to find the last point was yn is equal to n is equal to 3. Then only y4 will be coming. Okay. Okay, now, so f of x4, y4, I can put as, what is that? What is our function actually? Function is equal to xy plus x squared minus 1, isn't it? So here I can put x4, y4, 0, okay, plus x4 squared minus 1. So what do you think this one? So x4 will be, what is x4? So it is like 1, 1.1, 1.2, 1.3. What is the next one? 1.4, no? So this is what we are finding. So 1.4 times, what is our y naught 4? This is your answers. Okay, this is your y naught 4, y4 0. Okay, so substitute that value. Because in this method, in the prediction only, we are finding the correction. Okay, So here you can put your value 1.264289583, whatever the value. Okay. Again 1.4 squared minus 1. Can you find this one? That will be the final answer if you put this one. Okay. 2 is that correct? I have one of the answer 005417. Okay, keep your limit this one like this because you are using calculator, no, so no problem, you can use as much as it is. Okay, this is correct for the F40. Mm, 5417. Okay. It's a 30. Okay, 30 is that correct? So I'm waiting for your answer. Whatever the answer you're giving is what I'm gonna write. Okay, 16. Someone has said 1617. That's not a problem, no? Okay. Maybe you get 16, someone get 17. That's not a problem. Okay. All right. So we have found F naught 0. Okay. What about this other values? 9 times F40 again 19 plus 19. Okay. Plus 19 F of 3. No. Please check 5 times F of 2 plus F1. So you have to keep it in mind. In the correct equation, we don't have the F naught, but F4 naught is there. Okay. So since this implicit, see, still we are finding F4 of 1, but F4 of 0 also involving. Okay. So that's what we called as a implicit case. Okay. Okay. Now that's all. Just substitute the values. Yeah. You know this one, you know this, and put it on. Okay, let me use it. So what is actually, we have y4 of 1, step number 2, y3, isn't it? Y3 plus hy 24, 9 f40 plus 19 f3 minus 5 f2. Again write. So then only it will be memorized. Okay. Okay, y3 we already found, sorry, it has given 1.028. Okay, h is 0.1, that is okay. So 9 times, so what is F40? 2 point, what is that? Give me a second. 7300. Shall we put 5416? Okay, 16 or 17, anything. Okay, 16. Again 19 times. So what is our F3 actually? 2.0264, no? Again 5 times 1.464. These values have we already found. Okay, give me a second. Bye. 1.46. Give me a second. Okay. Again, 1 time 1.014. Okay. So just substitute and finalize the answer. Okay. One has answer like 1.264507286. Is this correct? Okay, 264507286. Okay. So see here, until the four decimal point, it is coming nearest to the y40, no? So you have to be careful even when you are doing the examination also. You can correct your answer because you have to have something somewhere, it should be near. Okay. So this is actually, numerical is not a big thing. That's why we have studied the error terms for, as first. Okay. So it is a minor, small differences because we are seeing nearest one. No? So they have corrected from the prediction to the correction. We have a small difference only. In our y40, we have what you got? We get the answer somewhere like 1.2628, is that 9583 or something, no? So it is somewhere related. Okay. Okay, now go for the step number 3. So you have to find the difference between that times minus 19 divided by 720. Okay, so let's go for the step number 3. Okay, step number 3, where you have to for the d4, dn plus 1, no, d4, which is equal to minus 19 over 720, which is equal to yn plus 1 of 1 minus yn plus 1 of 0. So there may be a small difference, 19, 720. So put your values and find the answer. Maybe a very small answer. 10 to the power of minus something. Okay. Nine point 264507286 minus 1.22645. Sorry. What about that value? 264289583 or something. Okay. So what is the final answer? Yes, good. Something minus 5 times whatever the calculator will give you the this, what do you call this one, significant figures value, you can give that value. Okay, 10 to the power minus 6. Okay, yes. So we have found the step number 3. Everyone doing 7 4 5, somebody has given the answer like this. It's okay if it is a minor values of minor differences, but check yourself. Okay, you don't get a big difference yourself. Somebody has written this one. Okay, when you are doing again, please try whether this value okay or this one. What about others? Which one correct? Okay, 9. Somebody has answered different one. Okay, this one. Okay, one more person has answered this one. Okay, similarly, step 4 is very simple, isn't it? Step 4 is, it says, therefore, we have reached our answer. Yx4, which is equal to y of 1.4, that is our question, which is equal to yn plus 1 of 1 plus this d4 value. Okay, d4. Okay, can you add this one? So this may be something like 1.264507286 plus, sorry, minus 5 times 744940278 times 10 to the power minus 6. Just feed the values in the calculator and find the value. So you don't need to worry. You are not doing manually now. So what will be the final answer? And the approximated final answer with some, let's say, 4 decimal places. Okay. So this is your answers. So 1.264501541. So approximate value will be 1.2645, isn't it? So 4 decimal places. So you can cut off. Okay. See. So actually our y04 is the one we have predicted. Okay. Predicted value somewhere y0 has been given 1.264274. Okay, but we have improved that one doing the correct value and doing some steps. We have found our final answer would be 45. So the 4 decimal point only changed. All the other points are okay. This point we have to correct it. So that's why we did the corrected method and that D4 and then edit. Okay. So can you go through the again? So actually nothing. So when we see, it has been seen very difficult one in the notes. But actually when you are feeding with some numerical values, it will be easy. See, they have given your function. So whatever the dy or dx, you have to take as a function of xi, y. Okay. So this has been given as xy plus x square minus 1. H also they have given. So this also they will give you. Okay, don't worry. I have missed to type it. Okay. So only thing you have to know, if it is a 4th order one, you have to get y0 to y3 you will get. So y4th one only you have to get. Okay. So x0, so x1, even though x1, x2, x4 not given, they have given the steps no. So you can add, okay, up to 3rd and 4th value as well. And y0 they have given some data, tabular values. Okay. So using these values, we are going to find our answer. I mean the asked question. So for that, first of all, they have you have did using the fx comma y. So you are feeding x0 y0 as f0. We are abbreviating simpler form. Okay, f0, f1, f2, f3. So first of all, you find these things. Okay. Then what you do is you write the step number 1. So you have to know n is equal to 3. Since 4th order, n is equal to 3. So this is our prediction equation. Okay. Somehow you have to memorize this one. Okay. So then if you feed the values, okay, we have found our answer is 1.2642, something like that. Okay. Then what we have done is we have moved to the correct. Okay. Before that, using the corrected method, we need to find this one. So rather than finding after this, you better find it earlier. Since you know already y40 you already found. So using that and the x4 value, you can find our function value of this one, f4 of 0. Okay, you can substitute the values x4 and y40 that we have found in our prediction value. Using that, you can find this value. So in the correction, it is an implicit method. So y41 is equal to y4, and so this is the only thing you had to find it earlier. Okay, these are already you have found. Okay, so then if you substitute in this equation that values, okay, you will get the equation 1.2645 something. Okay, we already found the answer. Okay, but we have to do the correction between the predictor. Okay, so that we are fine. So you have to know when you are doing step 1, step 2. Okay, step 1, step 2, you should know, okay, my answer is this one. Okay, you already know the answer, and see whether you are not deviating much. Okay, when you are doing d4, d5, so sorry, d4 and step 4 also, you have to be clear. If you get, for example, let's say this is the same question. If I get step number 4, let's say 1.75893 or whatever, little very deviated, or 2.7. So you have to know, okay, I made a mistake somewhere. So you go back and correct your answers. Okay. So this is how you have to know. You have reached the answer, but you are correcting yourself. Okay. You're finding some difference and then adding with that. That's all. Okay. So since we are adding the same thing, it is only deviating with this, see, 10 to the power minus. Okay, whose mic is on? Let's hope you have mics. Okay, so this answer for this question number 1. So let's do one more question, so it will be more familiar to you. So that's all I wanted to teach you today. Okay, and after this we can okay, do it yourself and give me the answer only. Okay, so it will be easier for me. Start to do the second question. Third one is your homework one. Okay, can you do the question number 2? Okay, let me go back to the question. Okay, question number, same question. See, using the Adams-Moulton fourth order prediction corrector. So this is how one of the questions gonna come. Okay, so you don't need to worry. Only thing is you have to, practice yourself to memorize these things. That's all. Okay, and y at 0x0.4. They ask 1.4. So you should know. Okay, I'll give you these values. Okay. Yeah. So x values are not given. I'll give you the y values only. Okay, y0 is equal to 0, y 0.1, 1.105513. Okay, y 0.2 will be 1.224208, and we need one more thing. This will be, let's say, 1.37359576. Okay, using these values, can you find the answer and answer me? Okay, within 10 minutes, 15 minutes, you have to answer me. I will write your answers in the whiteboard. Okay, so the third one you can do yourself. I think in the third one I have given this one. Okay, I think I missed here these two. So x value, I hope I don't need to give you, no? So if you know h value, and see, this one is already there, no? 0, 0.1, 0.2, 0.3. Sorry, this one is 0.3. Okay, so there's nothing. Okay, let's begin. Can you begin the answers and give me the final answer? Yes, thank you. So 0.3. Okay, please write down this one quickly. Y not 0, y1, y of 0.1, 1.105513, and next one 1.224208, next one 1.359576. Okay, begin your work with the steps what we have done from the earlier question. Do all the steps. So can you answer me these things? F3, yeah, F3. So you substitute everything. You write nicely everything and final answer. Give me the final answers. So this is a very simple function, so no need to worry. Xy is equal to y plus x squared. Very simple one. Okay. Okay. So first one obviously 0, isn't it? Next one. How come 1.16? Why not is also 0, no? 0 plus 0 will be 0, no? 72, can you correct two answers? So y of 0 is equal to 0, no? So x also 0, y also 0. So altogether 0. Okay. This one, okay, 115513. What about F2? Okay, 1.264208. 1.449 576. Good. Okay. These others 003. Everyone, please correct your go and check again. Oh, 49576. No? Okay. Okay. Now let's begin the steps. So n is actually 3. Okay. The fourth order always should be 3. Okay. So now write down the step 1 and then find the y4 of 0. Can you substitute and find the answer? Also f4 of 0 is what? Okay. So 1.552960954. Okay, good. What about F4? Okay, good. Substitute that one in here. Okay, 1.7129 6054. Okay, is this correct? Okay, if you finish, go for the step 2. So what is y4 of 1? Just substitute these values and find the answer. I'm waiting for you. Please answer me. Okay, I got one of the answer. 1.5168. Others are why so silent? If you don't do now, you can't do in the exam. So it will be very difficult. If you used to this practice only, you can do in the exam. Don't wait until the exam to do these kind of questions. Okay, do it you have enough time, like 2 or 3 weeks for the examination. So please try yourself to get into the things. So maybe like 1.5169 for something. Okay, just put like that. Yeah, go for the step number 3. Is this correct? Others? If you write in the notebook and then substitute in the calculator only, it will be easy for you. If you just watch yourself, it won't work out. Okay, just do it. 6880, correct, no? Okay. So go for the step number 3. Whoever finish. Step number 3 and last point, 4. So if you practice the steps, it won't make any mistakes. So what about dn plus 1? I mean d4. D4 must be something very, very like a error, no? Very, yeah. Okay, I got one answer. 5.5, 9.52, and 1, 2, 4, 6, 7, 5, 10 to the power minus 4. Is that correct? Okay, now go for the y of x4. It means y of 0.4, which is equal to, you can add this and these two. Adding these two, you will get something. There are 97 students here, but only 1 or 2 only answering. So can you answer me for this one? Okay, so 1.5, is that 57? Check your answer, because there are some 5169 something only. You have to, in the 4th digits only, you have to have some difference. Can you try again? This and this plus this make that much difference? No. 51 should be. Can you redo again? 005. So if you add these two, it must be somewhere very, very near to this. 5783 can't be. Just add this and this, these two. Okay. 51783255. Is that correct? Okay, somewhere. Yeah. So maybe the approximate, now we can approximate at last point. Okay, 5178 isn't it? That's all. Okay. Sometimes they may ask you with the 3 decimal point, 4 decimal point. So according to that, you can approximate. Okay. So there's nothing, just calculations and you have to memorize that prediction corrected things. So is this final one is correct? Can you finalize, everyone? What about others? Is this correct? Final one? So why I have stopped to write of one of yours? Because if I get 5, 7, something like that, so I can understand. So here we have 5, 1, no? So at least whether this must be wrong or that must be wrong. So you have to be somewhere near to, because this is very, very small one, no? When you're adding this one to this one, it will go very small different, not the big one like 5, 7 like that. So that's why I told you to check it. Okay. So is this correct? One more person. Two has, okay. What about others? One or two person, please confirm this answer. Others doing or not? Yeah. Okay. Good. Thank you. Okay, that's all about the second question. Okay, thank you. So third one, I don't know whether there's third one, no? Yeah. Third one, I have one answer, but I'm not sure. You can check, okay? YX4 maybe something around 0.9628. Maybe wrong or correct, okay? Something around it, okay? Check it. So that is for your homework, okay? So that's all about our course, okay? So that's all I wanted to teach you, okay? Okay, let me go back to our, yeah. Okay, let me summarize our, okay, give me a second. So this one, you just try it, okay? And also one of the reference. So if you know this one, this is very simple, okay? Just go through one of the video or any book references, okay? That's enough. No need to, you know, so that's just for your references. Okay, this is actually our coursework, numerical analysis 1. So you can consider there is another, following course also maybe, okay? Maybe in the next semesters, okay? All right, so aim of this, okay, see whether you have gained all the aim and outcomes, okay? To solve the algebraic and transcendental equation. Transcendental in the sense like, for example, trigonometric, okay? Trigonometric. This algebraic, y is equal to x square minus 1, something. This kind of equation we called as algebraic, okay? Transcendental, maybe trigonometric, okay? Any polynomial or exponential function, sine, cos, those kind of equation we called as a transcendental equations. So you know that things, no? Okay, now next one, to calculate the derivatives and integrals and to perform an error analysis, okay, for various numerical methods. So hope you know all these term words already, okay? Okay, next one, let's see how we have gained our learning outcomes possibly, okay? Some maybe omitted because of the time, durations. That's not a problem, okay? Okay, the first one, represent the numbers used in text computer arithmetic, okay? So numbers and number system and errors we have studied in our chapter number 1. Okay, that is our learning outcome 1. Okay, which can be gained from the chapter number 1. So go through the number system and errors. Okay. Next one, solve an algebraic or transcendental equation using appropriate numerical methods. Okay. So we have seen solution of the equation one variable, like algebraic one variable equation. We have studied bisection method, fixed point iteration, method of false position, Newton-Raphson. Okay, all four we have studied. Okay, so you can go for the chapter number 1. All these together will have one question in our chapter, semester. Okay. Okay, similarly, let's go for next one. Solve a linear difference equation using numerical method. So in this, I also have given you some reference, as well as I have taught you the Newton forward as well as backward difference method. Using the table formula of forward, backward, how you can solve it. Okay, so we have done that. So that one coming here. Also in the chapter 2, we have studied collocation, polynomials, some of the polynomials, collocation, factorial polynomial, oscillating polynomial, and Taylor polynomial. Okay, so go through these by one. Okay, then also linear difference equation I have given you as a reference. Okay, and also first and second order, you can try the that questions. Okay, so it is also there in the semester paper. Okay. Okay, next one. What is our third one actually? Okay, next one, approximate a function using an appropriate numerical method. So, okay, that is we have studied for the polynomial. Okay, we have studied polynomial. First of all, we have seen the introductory part for the polynomial as well as different kind of polynomial. Also, we have used Newton's backward and forward difference. And then interpolations, we have seen forward, backward difference, interpolation, as well as Lagrange interpolation. What about extrapolation, as well as inverse interpolation? Okay. So here, error in the interpolation, I have given you as a reference. Okay. So whatever I gave you as reference, sometime I may don't take the question, but you have to know those things. Maybe sometime I may ask in the continuous assessment, if not in the semester. Okay. And the final one, we have seen how to solve the differential equation using the single step method as well as the multi-step method. Okay, that's all about our coursework. There are, it is a 2 credit one. So you may have 4 questions in your semester. Okay, so for the time scheduling, okay, you have only 1 or 2 weeks now. So what I have told to our other lecturer as well. So he said me to make the continuous assessment into 2. Okay, only 2. So it is easy to do that. No, maybe chapter 1 and 2 in 1. Okay, chapter 1 and 2 in continuous assessment 1, and 3 and 4 in one of the continuous assessment 1. Maybe if possible, we'll do in a 1 day or within that, like what that I have messaged you, from 18 to 18, 19, 20, 21, 22. Only this is a no, 22 also holiday, maybe 21. Okay, there are only 3 days. Okay, so you next week I won't have you have the lecture, so I'll give you for you to prepare yourself for the continuous assessment. Okay, so at least this time you take your notes and study. Okay, so I know you all are busy, but better you to prepare before coming here. Okay, if you come here, I will put 2 continuous assessment. That's all about the continuous assessment, and the semester you can it also can be happen soon. Okay, so that's all about these courses. But I have seen only few of you has filled that evaluation form. Only 50 or something only We have 108 people here, but only 52 has filled the form. Okay, that's a very important one. This time they are doing some analysis with that. Please, can you we have 50 minutes now. Can you all others, okay? If you wanted, if you done, you wanted me to put the message in my numerical analysis in our group, okay? The group I am messaging you. Can you put the message like done? Okay, whoever not done, please do it now itself. I am waiting 15 minutes. You have to do it and put me the done with your registration number. You have to put as done like that. You have to message me now. Okay, so I'm watching you. So within it's only you need 5 minutes, no? So can you all finish? Whoever finished already, please put your registration number and put the message as registration number done like that. Okay. Can you all support me quickly? So if you finish, I can finish today's lecture. Okay, same week. Yes, both will be happen same week. That's why I'm finishing this week itself. Okay. Also, one of the happiest news, if most probably for you. Okay, I have all these online lectures are recorded with me. Okay, I will collect and put it in one of my channel and I will share for you. Okay. So whoever missed or whoever already there missed some things, or for the study purpose also, you can use it. Okay. I will collect and I will upload and I will send you. Okay. So only thing is it will be in, I think, YouTube. Okay. So possibly you find any um, unlimited YouTube data package or anything. Okay, so you can re-study again all the videos. Okay, so I will upload it soon. Okay, let me see. Okay, good. 2, 4, 6, 8, 10, 12, 13. Okay, whoever done, please put the done, and who are not done, no, please put it in the WhatsApp. Okay, not in our this chat. Put it in the our WhatsApp group, not in the main group, our group. Okay. Similarly, the PDE people also will have next tomorrow's last lecture. Please, if you don't fill that form, please fill it today itself or before our lecture. Please fill it. Okay. Put your genuine feedbacks. So prepare yourself like the semester. So you can continuous assessment is not the problem. So you can do all question in one day itself if you prepare like that. Okay. So hopefully today I will put the video playlist. So, find a way to see the unlimited YouTube or something, so you can access anytime. Till 63 something. Okay. If anyone have any doubts or anything, also you can ask. 25 to 30 people more. Yes, others make it faster. So I think there's only 25 or something questions. So 81 already answered. So 25 people are remaining. Okay, I'm finishing my lecture and I will soon upload the videos. And others who have not finished the feedback form, please put your registration number and done after you finish, okay? Within today. Okay. Okay, thank you everyone and best of luck for your exam preparation and for your exams, okay? Thank you very much. Take care.